some point the stream can start.
What's that?
At some point the stream will start.
Some point this will start.
The stream will start.
I see. That's the locker.
Turn the filter on. What's happening at WM? One of those days.
Okay.
One of those days.
That seriously sounds like a wiggle recording.
Yeah. Okay. Looks like most people are gonna be here, so let's get started. Everybody has sliced pizza, it's ready. I think we'll kick this off. So yeah, thanks for coming to WebDev this month. Still doing this, gonna have another one next month. Don't have a topic yet or a speaker, so open to anybody who has ideas about topics. If they want to do a talk here next month possibly, so hit me up. Thanks IDX as always for letting us use the space. Let's get started a little late. So let's just kick this off with Ryan.
Hello. So tonight we're going to talk about continuous integration and continuous deployment.
Might take a second for it to figure out what's doing. Is that not working in?
Unless I'm doing it upside down. I don't think, well, how am I doing upside down? I just did negative numbers? No?
I don't think that's. Turn it on.
Oh, it's like that.
Oh, okay.
You're supposed to be playing it.
Try to get a little closer.
The bottom, that's not pretty good.
Yeah, it's like, turn it off. On the side.
Isn't it that, the computer there that it's the receiver? Or where's your receiver?
One second.
There it is. So I'm Ryan Olds. I'm a software engineer. I work remote. And I have a wonderful wife and 3 cats. If you have any questions,
He was in front of the. No, wait.
that's part of the one that I get. If you have any questions or comments, just raise your hand. This is like, yes, Alex? Matt, sorry.
What are your guys' names?
Akam, Moxie,
Very good. Now I believe you.
yeah, if you have questions, comments, raise your hand. This is interactive. I'm not on a script, I have a script, but I'm maybe off of it, maybe fumbling. We're just gonna have a good time and hopefully learn some stuff. Raise your hand though. Stop there, telling you it's not working. Thank you, Bart.
No, the white again. Going forward back there.
Got to think,
No.
remember to play the computer, not the TV.
Yeah, but I need to be able to. Okay.
Maybe switch hands. Don't worry.
So what is continuous integration and continuous deployment? How many people here have heard of these terms before? So for the people at home, 90%, 95% raise their hand. How many people do or use continuous integration at their work? So about half. And how many people do continuous deployment? A little bit less. So most people know what it is. People here, half people are half people are doing continuous integration, and the other half, maybe a quarter or 20% are using continuous deployment. So what do we mean by continuous? What we're talking about here is anytime a developer like pushes code, stuff like, but it's when we run CI/CD frequently. It's typically driven by pushing changes or merging branches, merging pull requests, things like that. And the idea is that we are running the integration steps and the deployment steps frequently, or as frequently as we are confident, right? It's not lag. So integration in the kind of DevOps context is we are confirming that what we just changed, like our changes work as expected, they're following team standards, and that we are building confidence that we can ship it, ideally frequently, and not just let changes pile up for 2 weeks and then realize there's a bug and make somebody remember something they did 2 weeks ago. We're shipping it as we're making these changes and as we're confident that these changes can be deployed. And the deployment side is a little more complicated. I mean, most people, except a small percentage, actually do continuous deployment. It is more involved. This is the part that you're actually deploying your code to a staging environment or to a production environment. And then an often left off piece is infrastructure. A lot of us, I'm sure, initially go and stand up EC2 instances or can stand up Elastic Container Service cluster and some tasks. And we deploy without really updating those. Like, we don't version control that infrastructure. So a piece of continuous deployment is not just shipping your application, but shipping changes to your infrastructure and being able to stand up, ideally, multiple environments. So you can have a production environment and a staging environment and a QA or however many environments you need. And a common question is it worth it? And as with most things in software development, engineering, it depends. It really depends on how frequently you're running these tasks, like how often you're changing code, how complex the actual integration steps are, and how complex the deployment steps are. The more complex things are, the more it's worth it. But it also requires additional tooling, it requires additional skill sets. And I don't know if people have looked at like Glassdoor, but DevOps engineers are a little expensive these days. I personally do it with all of my personal projects. Like this presentation we're looking at is run on a Kubernetes cluster I have at home, and I use GitHub Actions to ship every change I make. It just deploys, takes about 5-10 minutes. I'm using RDC things. Some of the primary benefits to CI/CD is that you ship smaller changes, and you can also roll back smaller changes. You can ship those changes more quickly. You're not letting them pile up, like, in 2-week cycles, and you have a QA team that then looks at things done 2 weeks ago. What your engineers are doing is they're shipping the changes as they make them and as they are confident in them. And the CI part is really about building that confidence. Another common question that I get is it worth it for small teams? And this, as with most things, it's my experience is I firefight less if I have this structure in place, even if it's a project with 1 or 2 people, because I don't ship broken stuff to production anywhere near as often if I have a staging environment and I have something checking my changes, letting me know that the build didn't pass, or a linter if I even implemented one is failing, or the tests if I even implemented them, those are failing. Max.
How does that mean to the CIC? I mean, that's just testing, just running tests to make sure.
So one thing with CI/CD is it helps keep you honest. In smaller projects, if they have a big file, which I do the vast majority of times, I can run make lin, I can run make test, I can run make build, I can run all the make targets. But we're human. I don't always run it. Sometimes I'm just like, oh, there's a bug, and I need to fix it immediately. I just go and fix the bug, and I immediately ship it only to break something else.
Fair, that's automation. But then why is it, what's the advantage of doing it continuously as opposed to something automated and doing it on demand?
I think that's what we're talking about. It's the same thing, right? Like this automation, the continuous bit is we are hooking this up to like GitHub or your version control system, whichever one you're using. Could be Bitbucket, could be whatever. We're running it every time, and that is the automation. That is what we're talking about. Is CI/CD is all that automation stuff that the DevOps engineers are usually thinking about. So to answer your question, this is an implementation of the automation we're talking about. So it's one of the strategies. One thing I want to highlight is on smaller teams, it's common to have a lead that ends up doing everything. Like it's their job to SSH into the machine and run git checkout, which you should not do in this place. Don't do this. Use containers. And use a container orchestration service. But you SSH in, you deploy the code, you bounce Apache, do a bunch of stuff that like manually, that person is usually your lead, and it's very difficult for them to not get interrupted with somebody wanting to ship code some week. It's very difficult for them to take a vacation and not get a message saying, hey, can you get to your computer real quick? We're having an outage and we have a fix, but you're the only one that can deploy this. And when you have CI/CD in place, that lead can go on vacation. Your team of your 1 or 2 other people on that team can still ship code. They can merge those pull requests, and they can still ship that code. Where it gets to like kind of, is it worth it? It does depend, and it really means you have to kind of judiciously. And the chart I use, and I hope everybody can see this, is this fun XKCD chart where it talks about how frequently you run it along the x-axis. And then down the y-axis is how much time are you shaving off. Oh, there we go. Sorry. How frequently you do it, how much time you shave off the process, how much time over 5 years, which we'll talk about in a moment, how much time it's worth in my mind, divide all these numbers by 5. Because I'm not gonna be able to go to a project manager and say, well, here's, we can save X amount of time. They're gonna be like, oh, shit, like, I'm not even gonna be in this company. So I divide these by 5. Because I typically can get a project manager to care about the next 12 months. And if we were talking about the next quarter, these numbers would be so tiny. But really, when we talk about like things that are done daily, which is what we're talking about, being able to ship code daily. If it takes 30 minutes, like if you can shave off 30 minutes from the deployment process, it's worth 6 days or even 5 weeks, according to this, over 5 years. So divide that by 5. If you can shave off that deployment process, or shave off the manual process, if you can do that in a week and shave off 30 minutes, that's worth it. Or you can do it in, let's say, 1 minute. So what does continuous integration and continuous deployment look like in Rails? Like we have a rough understanding of what it is. We're automating our workflows. What does it actually look like? Well, the first thing you need to decide is how you're going to run those workflows. How are you going to run those steps to do the continuous integration as well as the steps to do your deployment? Also, what infrastructure tool are you going to use if you decide to use or you decide to do infrastructure as code and be able to, as part of your process, make changes to AWS, like DNS records or create buckets or that kind of stuff, rather than having somebody do it manually. And then also, what does it look like to the developer? And what does the implementation of those workflows and driving those workflows look like when they are interacting with, pushing commits and merging pull requests? And then also, what does it look like to run the integration? What does that integration look like? What does it look like to deploy to your pre-production environment? And then what does it look like to deploy to your or promote to your production environment? So common workflow engines, this is the first thing you have to decide. The popular one, the one that I use 90% of the time, is GitHub Actions. It works very well. It's YAML file. Cloud providers also have a lot of these. Amazon has CDK, Amazon has Code Build, Google has just as many, Azure has just as many. Some people use Jenkins. Jenkins is a great tool. I have used it for many years. It is more recently following the newer DevOps style of doing things. So it's added the ability to like version control your workflow in your repo, or even have your repo be a first-class citizen in Jenkins. But those are relatively new, and I don't think they're integrated super well. So I would recommend sticking with your cloud providers, or whichever one like your version control software provides. Like I forgot what Atlassian has. They have something. Is it Bamboo or, Chris? Is it Bitbucket? That's the version control. What work
built into it? I don't know what the specific.
Okay, yeah, so Bitbucket pipelines. And there's many more. There's like Travis CI will do a lot of the work. There's Circle CI. A lot of this stuff will be a workflow engine. You can use it in that fashion. The next decision you want to make is, what are you going to use for your infrastructure code if you need it? You don't always need it. If you're running a single environment or 2 environments, ideally, and they're set, and you don't intend to set up any more, you don't intend to tear those environments down and reconfigure them and reset them up again in a reproducible way, you may not need a infrastructure as code tool. You can kind of skip this or defer it until you do need to start reproducing your environments. And then commits and PRs, you need to be able to drive your workflows from your version control software. GitHub Actions, as I mentioned earlier, is super good for this. They have their GitHub Actions. It integrates almost seamlessly by just dropping YAML files in your repo, and it just works. The pricing model isn't too bad. When you get to be a big company, it will start to cost you tens tens of thousands of dollars a month. But you gotta be a pretty big company before you get to there. And then integration steps. So what are we running when we do we push changes to GitHub or whatever version control software we're using? Typically, the integration steps look like the workflow checks your code out, checks your project out. It'll install whatever dependencies you need. You'll run a linter, you'll run your build steps, and you'll run your tests. And then you'll typically build your image just to make sure that it builds. What you don't want to have happen is skip the Docker build step or the image building step, and you find out when you go to deploy that your Docker file is broken. You typically want to make sure that you can build your image as a part of integration. You don't necessarily want to upload it anywhere, because now you're just chucking 100 megabyte images, if you're lucky, smaller, ideally. You're just chucking that up and eating storage space.
So for image, when you say image, could I interpret that in, like, if I'm building an NPM package, I'm not building a document, I'm building a JavaScript library and a bunch of associated files. I still want to participate in all this.
You can just skip that.
So I would just replace image building with, I actually just.
I would count, so I would just skip the image building. Well, so you could build your package and not push the package. That is what I would recommend doing. It's just like, you can do NPM, pretty sure. No, I think you just do NPM build. The pushing it to your NPM, like upstream to NPM, that is a deployment if you're talking about a library. Like you're making it available. That's your deployment. I would not do that in this step. I would do that after CI passes and you merge your pull requests into like your main branch.
Got it.
This is where it gets a little weird. So, well, I mean, to bring up what Dan brought up, deployment, you're going to have to kind of squint a little bit. Look at this various thing. What does it mean to do a deployment? And that's making your code available or making your service available to other people. Sometimes that's internally, like if it's a test environment, or sometimes that's your actual customers if it's a production environment.
Yeah, it just seems to me that image building is really part of it's the first step in the deployment.
So yes, the way I think about it is pushing the image so that it's out on the cloud and taking up money in my cloud. I do that as the first step. Ideally, I just let the build happen, and then if that passes and it's like the main branch or my release branch or whatever my production deployment branch is, that is the next step is to push. But I want the building as a part of the continuous integration, because if that fails, I want the integration process to fail. But I also don't want, let's say I'm just doing commits. Let's say I'm just a branch open. I'm just pushing code and iterating, just fixing things. And what I don't want to have happen is I'm constantly pushing 100 megabyte images up that I do not intend to deploy. Those will add up. They do cost money a little bit. We're talking cups of coffee, fractions of a cup of coffee. But you don't want that to happen when it slows your build, your CI process down, because that does take a little bit of time to output. And when we get into like CI/CD, these processes often take 5 to 10 minutes. And you want to shave and be judicious about it. And kind of back around to deployment. So now after the CI part passes, now it's time to, if you're using an infrastructure as code tool, run that, make any buckets, make any DNS records, make any RDS instances or manage SQL databases that you need, that kind of stuff, or update them. Maybe one of the change you're shipping is you're increasing the memory on your managed SQL instance. That's a change that would be there. You would commit that into your IAC code, your likely YAML files or Terraform files or whatever. And commit that, push it, and those updates would happen then. And then possibly you would then make calls to the provider, or Kubernetes, you can view pushing Kubernetes resources at but you make API calls possibly to deploy your service, like if you want to update a task in your service. And then if you're using a container orchestrator like Kubernetes or ECS, you can then just on that and just deploy that new document. Just let the computer administrator do its thing and roll all of your workloads so that they're not running the new document. So now you've let's say you've merged to main and it's been deployed to your testing. We're now at a point where we want to build additional confidence. We're not about to break production when we promote this to production. And that confidence building comes in. I'm a fan of manually testing the things that might change. I go in and make the API calls, I go into the UI, and I push the buttons that are driven, that would drive the changes. Other options are, and this, I'm a fan of this, is implementing automated intent. Once your system ships to test, it kicks off a whole separate process that goes and makes customer accounts, and makes all the things, and completely validates that a customer can come in, make an account, do common things that you're like, common stories that your product managers are talking about, and make sure that that all works. And it's your testing environment. Who cares if you've made a bunch of, fake data? That's what this is for. That's a lot of confidence right there. Another one that we do, or I will sometimes do, but don't like to talk about, is if you have a staging environment that your company is using and you have a lot of engineers, you can do what's called a screen test. And you just deploy to testing, to staging, and you just wait a while. See if anybody comes to your door yet. If anybody's in a channel, that's something in the testing environment. This is not a good practice, but it's a common practice. The other one I like this one too, is you run all of your same alerting and monitoring systems on the test environment that you do on production, and you hold them to the same standard as production. My belief is if you can't deploy to staging without breaking staging, then you can't deploy to production without breaking production. And so I like seeing alerts and monitoring in staging environments or test environments, because it's nice to see that those things aren't breaking. Like your error rate's not going up, your latency is not going through the roof, things like that would be indicative of a problem. And then on to promotion, and there's a few ways that I've seen this done. There's manual approval. That is not continuous deployment. There's another term for that. That's more manual. The other term is eluding me at the moment. Using different branches for different environments is one of the more common ones. So main will deploy to staging or test, release branch, or usually a release branch, or some other named branch. When you merge code to that, will deploy to production. Another one, the company I worked at a few years ago, they did baking. So when you would merge to main, it would kick off a 60-minute timer, and it would automatically promote to production after 60 minutes. And that was actually nice. I actually liked that. It gave me 60 minutes to go and poke around, give me 60 minutes for a screen test. It gave me 60 minutes to make sure that the alerts and monitoring didn't go off. Things like that made me stop and gave me time to breathe and go poke around.
So with that setup, did it give you an easy way to cancel that 60-minute timer?
Yep. Yeah, there was an interface. I think they had their whole deployment interface, and you could just go in and press the cancel button. So now we're going to get to like kind of the fun bits here. Let's kind of step over here off camera. This is some of what the repository looks like. If you're using GitHub Actions, and this is a hypothetical service that's being deployed to a test environment and to production. And in this case, we have 3 GitHub workflows defined. One is what happens when you commit and push code to a branch. The other one is what happens when you merge to like the release branch. And the test workflow is when you merge to main. And then we have a Helm chart, which is what we use to deploy to Kubernetes, which is what is being run in the test environment. That is ECS in this example, which we'll get to in a moment, is what the production environment. And oh, and there's a make file where you can do all your make, win, build stuff. So this is what the commit workflow. So as you have a branch, or and then actually this gets a pull request. As you synchronize, you open the pull request, you synchronize it, or you closed it and you're reopening it. This workflow will run. And the kind of the key bits here is on, on pull request and these types, we're going to run a series of steps that are not shown. We'll look at those next on a Ubuntu latest Docker image. And I think inside of the Docker image is better. So here's the steps for where those ellipses are. And the first step is, in my case, it's a Golang application. That's kind of my de facto, that's my standard these days. I'm setting up Golang. I'm installing the Golang, tool chain and all of the tools. I'm checking out the repo. And this is all automatic, but GitHub knows what repo you're in. You call this action, you'll just check it out and copy it into that Docker image, that Ubuntu Docker image that's actively, but these are being run inside of. I'll run lint, I'll run I'll build the binary, I'll run the test, and then I will build the Docker image and not push it. And this is the test workflow that will run when I push to the developer. Similar setup, Ubuntu latest. It's all of those same steps as before, where the ellipses are. With the addition, well, actually the replacement of that last one, where we do the same build, but we tag it. Is that actually, I can't remember. Did I tag last one? No, there's no tag in this one. Because I'm going to push, I do a tag. Tag it with like my service and the Git SHA. Always use the Git SHA, like, or a version number. Don't use latest, just don't do it. You'll regret it. And in this case, I'm pushing a script. And then after that, in this example, this is going to a Kubernetes cluster that's running Argo CD. And I'm not going to talk too much about Argo CD, but it's a newer style GitOps technique or tool to do like the GitOps style deployment. And what I'm doing in this kind of blob, hard to read blob, is I'm patching this chart values file with the Git SHA, and I'm updating the image.tag path. And what that is doing is this values.yaml file. Actually, quick aside, who here has used Helm? Chris raised his hand before I even finished my sentence, he knew where I was going. So Helm is just a collection, a way of version controlling Kubernetes resources, which are just YAML files defining what a deployment is and defining what ports your service exposes, as well as the ingress to that service. There's more to it. It's much more complicated than that. That's the basic, easy, bite-sized what's Kubernetes. It's a thing that looks at that and sets all that stuff up for you and runs your workloads and makes sure that people can connect to it. So it is saying, here's the repo, here's the tag, and what it's doing is it's patching this SHA with the new SHA. And Argo CD, within a few minutes, 3 to 4, will pull that repo, detect that it's changed. It's not, the repo has changed, and it will then run that Helm chart for you, apply it to your target Kubernetes cluster that you have configured. And that configuration is all YAML files too, just like this is, but I'm not going to show those.
Hey, Brian?
Yes, but
So in the values.yaml, is that values.yaml considered source code?
it is version controlled and checked in. Yep. If we go back, it'll make a new commit with this commit message. Now, that does mean that if you're committing to main and stuff, you do have to want to push and stuff. It's a little annoying. At least in my example, these slides that we're looking at are hosted and they're deployed using this technique. It's a little bit annoying. The right way to do it is to have a second repository that is just your infrastructure YAML. It's not your service YAML. And you have Argo CD watch that. And you can still have your Helm charts and stuff. All those Helm charts and infrastructure, Kubernetes specific stuff lives in a separate repository. And you can actually dispatch GitHub workflows across repos and pass in metadata like that Git shell. That's not shown, that is an advanced topic. The time here. So this data, which is your values, when Argus CD hydrates your Helm chart, it's just taking those values and that image.repo and just kind of substituting this and deploying this deployment file. There's not a lot pictured. This ellipsis is hiding quite a bit. This is just the gist of a Kubernetes deployment file. It's got a name. It tells you what your containers are, what your image is, things like that. There's more. You can do environment variables. You can mount volumes on storage, on local disk, or network storage, things like that. Not pictured, not relevant. So this is what I'll deploy to my test environment. When we merge to the release branch, or whatever our production, this is where it gets really so it's similar to the previous one, but now the branch is main and not developed. Oh, you would do latest. Really shouldn't use latest. I'd use a specific version. I'm using latest because it doesn't matter to me. This is a personal project. So here's where it gets fun. So production is Elastic Container, ECS, Elastic Container Service. Who here has used ECS? Like a third. That's actually not a bad number. It's a great tool. It's like Kubernetes Lite. Works pretty well. So first things first is we need to log into AWS. Next, we log into the Elastic Container Repository or Registry. I can never remember what the R stands for, but this is just logging into what stores our image, what we're going to upload our images to. And then we do the same kind of like build image, but we're going to tag it with some slightly different stuff, like ECR, registry URL, the image tag, things like that. We're injecting that kind of stuff from the some GitHub metadata. And that will push the image up to Elastic Container. Is it registry or repository? Use repository. Okay, this one. So this pushes the Docker. Like this stuff logs into AWS, pushes the image up. Now for the really hacky stuff. So the funny thing is if you were to Google how do you deploy actions to Elastic Container Service, this is almost a direct copy. I think the GitHub Actions. It's GitHub Actions or on Amazon. I'm pretty sure it's GitHub Actions. This just uses the AWS tool to download the existing task definition that I have not version controlled. And deployed with like Terraform or something. It's just downloading it, saving it to a JSON file, and then I'm using this tool to render that task definition with a different image. And then I'm running another GitHub action that then takes that output of the task definition step, which, oh, I might have goofed. I think this says task def. I had to show up with some lines. So this should be task def. It should match the site. This then applies that updated task to ECS, which then it's a container orchestrator that just starts doing a rolling deployment. And that's how I deploy to production, using ECS. So what's missing from what I just showed everybody? I didn't show the Makefile with the linting and the build targets and things that run that. I assume most people here are familiar with Makefiles, they've at least looked at them. How many people here use Makefiles daily? That's actually fewer than I thought. That was maybe 25%. What does everybody use instead? What do you use if you have in your development environment? You want to run linting, you want to run the build steps, and make sure that it builds. What do you do? What?
Now we're doing a code project and not NPM.
NPM, okay, yeah, so using the NPM, like, the tag, like, it's what, NPM run and then a name, steps. What else are people using? Anything else? Is it just everybody using NPM? So you're using Makefiles. So, like, task files, I don't mention them here, but it's a newer one that I got introduced to a couple. They're nice. It's like Make, but purpose built for running tasks, and it can load a .m file, like an environment file, similar to what Docker can do, Docker Compose can do, and it kind of unifies stuff. It makes it all seamless. But Makefiles are what I'm most familiar with. I'm not showing the Argo CD configuration. So the Argo CD configuration, it's pretty much just saying, giving a repo URL, like, to the presentation, to the slides. It's doing that, and then it's saying what Kubernetes cluster you want to deploy this to, what namespace in that Kubernetes cluster is the target definition for the hydrated Helm chart. That's not pictured. I'm also not showing any of the AWS like infrastructure as code to stand up ECS. That doesn't exist. I did not write it. I do not intend to stand up another environment like that. It's just not worth my time. I'm more likely to stand up a new Kubernetes cluster using their managed Kubernetes service and moving away from ECS. I believe that is a better use of my time than creating those files. Also, what's not pictured is secrets management. And this is a complex topic. What is, if we go back a few slides, the secrets dot AWS access key and the access key, GitHub Actions will provide, or GitHub will provide some rough secrets for you that you can then use in your GitHub Actions. That's mostly what you'll need. When you get into big enterprise environments, secrets management will be a whole separate thing that you have to have a team manage. And you'll run like HashiCorp Vault, or you'll run some other, you run like a Amazon and AWS, all have their own secret management tool. You'll integrate with those, and that'll be a whole thing. When we talk about the maintenance overhead of like CI/CD and DevOps, that's the stuff, that's the big maintenance overhead, the stuff that's not fun. So yeah, didn't talk about secrets management. Hopefully it's not complicated.
In relation to secrets management, I was pleased that GitHub Actions recently had the ability to have variables that are not, that can still be visible.
Mhm.
And so those are nice for things that are configuration, but not secrets.
Yep. For some, sorry, no, that's yours. So something that Noah brought up is that GitHub secrets, it won't show you the secret. That's a nice thing. Like if I set up a secret, I don't necessarily want a coworker that doesn't have access to the shared, like, the shared password, the team's like, password management system or secret management system. I don't want them to be able to read it. Hypothetically, they could, so there's, it's not perfect, but they can't just go in and look at it. All you can do is update it. And they added some additional kind of environment variables see and Chris.
What would you say about practice for
Oh, some of my coworkers might be listening and they would have better opinions on this. I am not on that team. I'm adjacent to that team. I don't want to get into what my company's doing, one, because that's sensitive. I personally would probably just use Google's Secret Manager. I know they have one. I don't know what it's called. Just like Amazon has a secrets manager, I would just use the cloud one. If you're doing on-prem stuff, then that gets more complicated. And you probably end up running like HashiCorp. So we're kind of at the end. For anybody interested in messing around with CI/CD, this is the approach I would write that main file and be able to get it running locally. You can just run your linting, you can run your build process, you can run your test load. Once you have that, then I would create a GitHub action that just runs those make targets or npm runs, like whatever you're doing, it just runs it. And then after that, I would make sure that the GitHub action could build and push a Docker image to likely your cloud provider's repository. And then I would work out how to deploy to the cloud. And this is where you'll probably beat your head into your desk the most. But if you're running something in the cloud, ideally not EC2 instances, you totally can do that. You don't do it. If you're running ECS, you're running like Runner, Cloud Runner, whatever these various lightweight container orchestration services are, or the heavier weight ones, you'll have to work that out. There will be code online. You have to figure it out. And then if you really feel like beating your head into a desk, you can take what you have out in the cloud, figure out how to recreate it from scratch in a different, like a different AWS account or a different Google account, and completely stand it up with like Terraform or some other infrastructure as code tool like CDK or CloudFormation or whatever IAC tool you feel like using. If you get that far, you're pretty much ready to start working it like dozens, if not hundreds of other engineers. Any questions? See Max chuckling, and I don't know why.
And so the
Yeah.
that's
Yeah.
that was the pinnacle.
It depends on if you want to build a Florida house here. Chris.
In terms of what are the downsides to CIC? You know, like what are the pitfalls?
Yeah, so Antonio asked me to add more about that to these slides. I tried. My problem is I'm in the cult. I am like a member of the CIC cult. I run it for personal projects. If you go onto my GitHub account, if you look at anything made in the last like 3 to 5 years, it will likely be using GitHub Actions completely automatically deployed. There are downsides. It is more things to maintain. It does break, but you do have to maintain these images and things. But if it's something you're routinely working on, the benefit that you get from having all of that stuff automated and simply not having to worry about it. A good example is I can push a commit into a branch and just go sit in a hot tub and come back 20 minutes later and it'll be done and I didn't have to do it. Like it's the benefits and the upside is too good to not do it, even for small projects. I'm also to a point where I have enough boilerplate CI/CD code, like YAML files and various things in my projects that I can just copy and paste my way to standing up a new repo. I'm almost to the point that I have a Go template repo that just has all of this stuff ready to go, and I just copy the repo and write my Golang app, and CI/CD is already implemented. I just changed the not pictured as like the name of the service. I would just add a like service name to the values file, and I would just change that. And it would be ready to go to push images, it'd be ready to go to like ship it to Kubernetes, all of that stuff. We look at the deployment file. I would do one of these substitutions for the name. I would just substitute everything. I had to use it recently. I don't remember your name. Patrick? Yeah, Patrick.
Kind of following off his question, is there any, canonical example of a fiasco that was made worse by a bad continuous integration?
You can make any project worse by doing things poorly. You can always make it worse. Like I guess I'll extend this to the audience, and then I think Noah, you had. Can anybody here think of a reason not to use CIC or not implement this? Okay, I think the WordPress developers are about to raise their hand. Yeah, she gave me that. Yes, if I was running WordPress, I would not start that.
And that's fine. Our problem is supposed to be attached. We can't just let go. We have to, it goes. So we real. It's just, because otherwise it's not going to reflect, because it's going on with cash.
Are you not able to bake the? So, okay, so what Nicole brought up was some cache busting issues between, like, across deployments. So between one deployment to the next, there are files that are cached, likely in the browser cache. Browser.
Page caching, object caching, user caching. The first one is edge, local caching. Because it's scan the file player or scan like using your thing to get the caching.
The strategy that I see for that is anything that is getting cached, you include a key that allows you to cache bust, and you just tie that key to this shell. And maybe like a build count or something. Maybe you add a little bit more, like, I think typically there's well, so eTag is one example. eTag allows you to just change the eTag and that'll bust. You can also just bake the SHA into your URLs or into whatever your caching key is. And when this changes, if it's used, it will just bust your cache. Would that help your situation, Nicole? But you're hashing a file at that point, which is perfectly fine. That's just as good as this. That'll bust less frequently.
A lot of things like the small little kids that are attached, but there's always a main.js which is not attached and has to say that way. First,
Well, you should just probably hash that too.
yeah, not it's the other, yeah. Yeah.
Tag on.
Yeah, WordPress, like that.
But it's more of like the global CDN cache thing that you have. It'll cache dark pages, you know, so it's like you go. Global CDN.
So
you run the
typically
thing and
e-tags on anything that's like fetched over HTTP typically handles that.
I have a question.
Like,
So how do you handle database migrations, the ones that are hairy and potentially non-reversible? Do you handle that or?
so the non-reversible, let's set that aside. So just how do you do database migration? Why is this isn't breaking up? What I do, and there's different strategies for this, I have a that is a database migration service that is a separate binary that gets the migrations baked into it. I'm using Go, so I can just bake files into the binary, reference them as byte strings, you know, in the binary. I just put those in a binary and I run that before I deploy. So in this, actually, what I typically do is it's a separate service and a separate repo. I don't believe in ORMs. I personally do not like them. They cause more problems than they're worth. You're about 3 months into your project. And what I do is I put all the migrations on a separate service. I put CI/CD on that. And when I need to write a database migration, I make sure that what I'm doing is forward and backward compatible with anything reading the database. There should only be one thing interacting with that database. If you have more than one, you're doing it wrong. But you have one thing reading and writing from that database, one application. And you just make sure that it's forward and backwards compatible with that application, and you just do a deploy. And then you just wait for that migration to finish, and then you deploy your application. And if you need to roll forward because you can't roll backwards, that's just another migration.
What about things like schema changes?
Yeah, just roll forward or backwards if it's safe to roll that change. And I just change the schema, and if the and then I make sure that my schema changes are forward and backwards compatible with my application, because there's no other way to do it and avoid downtime. If you strictly tie, this is where ORMs will screw you. If you strictly tie your models in your application to your schema, you cannot guarantee that they get deployed in an order that will not break the application. You have to make sure that your schema and your application are schema changes you're making are forward and backward compatible with your application. Just period.
Does your applications usually read the schema on road?
No, I'm not using an ORM. I'm straight reading and writing SQL like it's like God intended.
I think it's still, there's
Right,
still.
Max is fine, because Max and I
I
understand.
think it's still possible to do both, so whatever, however you're using it, we don't usually have this set up as you have, you got your migrations, but they have a sequence, and, you're always saying this one runs, and this one
I'm
runs.
familiar, like, I'm mostly familiar with how Django does it. You have a full
Yeah.
setup to manage your migrations, but then every once in a while, or you're upgrading your Postgres version or something like that,
Yeah.
So
where
this,
you have something that has to basically ends up being.
Well, also, you could run your migrations in your CI section.
so here's the rub. The rub is, if you are running one instance of your application, you have pretty tight control over when things are deploying. The moment you're running things via a load balancer, you have n number of instances of that application running. If you apply a database migration, you cannot be sure that all of those instances of your application have rolled and support that new schema.
Right.
So the only way, and yeah, I'm sure if there's comments on YouTube, someone might argue with me, but they're wrong. The only way to do this and have zero downtime, which I care about. If you don't care about high availability, you can ignore what I'm saying, and you can use Django. You can use Active Record if you beat yourself. You can use whatever ORM you want to use. But if you want zero downtime when things are done correctly, by correctly I mean like they're done in the right sequence and stuff is forward and backwards compatible, you can get zero downtime with that. The rub kind of runs into is once your database is big enough, as you know, like you're a proficient DBA, those migrations can take hours to run. And are you just not going to roll your applications during that time period while your database is not in a consistent state?
Well, it depends. Does your database support MVCC?
You might know more about that than I do.
In theory, you could have a split view of your database. Often what you'll do is you'll stand up another database, run the migration on that, and turn off writes to the old one. So your system may be running in a degraded state, depending, I mean,
Is that something that
Depends on what
Django
you're
supports out of the box?
That-
Is that something Django supports out of the box?
No.
No. Like my experience is, and we're completely off in the weeds on a completely different. Right. This is the whole like, how do you do database migrations? Secondly, I find that if I have granular control over when I apply the migration, and I make sure the application is forward and backwards compatible with the schema, and of course, like tables lock and stuff, right? Like you're not gonna, what you're talking about is avoiding like table lock.
Right.
And still being able to support reads. In an environment where you have like message queues or like an event stream, then you can kind of just like stop your writes, let them accumulate, and once everything's in a state that can accept writes, then you can just catch up and not miss any writes. But now we are at enterprise level deployments at that point. Like once Kafka's in the mix.
Well, I mean,
you're-
at that point, I think you are dealing with a data team that is managing your database, and you do not.
Oh, that
You
gets
don't need to
into a
get
whole nother
right,
hot
you do
topic.
migrations directly to the database, you hand your migrations off to somebody else, and they look at them and say, oh, no, that's wrong, you have to do this all over again.
That's another hot topic. I'm a cross-functional team kind of guy. You have an application that needs a database and your team decides it needs a database, your team owns that database. Making someone else own it is just mean. Like making someone else responsible for like your schema changes and making sure that it doesn't foul up your actual application data model, like that's your job, not someone else's. I might get.
Except when you get to things that, the order book or something like that. It's not.
When your database is large enough, yes, you are going to have a team that's going to be managing that domain service, that's in charge of billing, and that giant billing database. And that's going to be a team of senior and senior plus engineers operating that giant database. But they should still, the team in charge of that data model and the database where the data model is getting stored should be the same. Otherwise, how are you gonna like make changes and not have the schema foul up on you routinely when you go to? I don't think you're anything.
Yeah, so my name is Ahmed, and I saw the question about CD and what was my All what I'm using CI/CD is either trying to make a good prototype of a project. Just like this.
You're talking, an MVP is what you're talking about. You're building a minimum viable product. No one's looking at it, it's just you, it's a prototype.
Like see something work
Yep.
or not. When you use CI/CD, database,
For prototypes that like no one but me is gonna look at, three screens. I would just do a mock-up at that point. I wouldn't even make a prototype. I would just use Figma, and I'm saying that like I would just use Figma and make a mock-up. I wouldn't even do the coding work. Because like if I'm not gonna use it or no, like, I mean, I guess what's the goal? Is the goal to prove that like a list can list things from a database? 'Cause we
projects and I'm learning something that sometimes you can't say for sure if it's gonna work, if this algorithm will work or not. So it'd be nice to just test it really fast and see if it works or not. So that's what I mean by prototype. So test things.
if you're using like Jupyter notebooks and you're doing machine learning, like let's say you're training a TensorFlow model in a Jupyter notebook, no, I would not at all ever engage CI/CD on it. Now, once I have my built model and I need to deploy that to like, I don't know what the current Amazon GPU instance, is it P2s? What are they now? What's the GPU enabled Amazon EC2 instances? P2s were what I used a few years ago, but I don't know if they're SageMaker. So if I add a model, like let's say I had a process that trained a model, I would take the model that fell out of that Jupyter notebook and that I might wrap a CI/CD process around to deploy to SageMaker. And that's really just making a model and then just like checking it in or putting it somewhere that the CI/CD process can deploy. And that kind of gets into Bud, because he's not here now. I think he left. He was bringing up like a NodePM package, and that really comes down to what are you deploying? Because that process is the deployment process is very dependent on what you're deploying and where. And it's going to vary. Web applications are going to be very different than NPM packages or machine learning models. Chris?
Are there any major differences between CI/CD or container service versus like Kubernetes service?
Can you repeat the last one? You said Elastic Container Service and
Versus Kubernetes? Like,
Uh,
are there major differences?
Not really. So, I mean, the answer is yes, there is differences. So right now, the modern way to deploy to ECS would be the hacking thing that I showed, or Terraform. It would be, is this the right one? Let's see, I'll just see the example, which is using Kubernetes. Second, just a little slower. So, it's this one. I'm not joking. This is pretty much copied and lightly modified from a GitHub, like an official GitHub Actions. How do you deploy to ECS? Like I'm not a genius. I did not write all of that. I copied it and changed like 4 things. This is how you would deploy to ECS. Another way would be to use Terraform. In Terraform, you would this output, this image output, you would inject that Terraform and then tell Terraform to apply. You would patch your repo with that and just run Terraform apply. That's the other one. For Kubernetes, the modern way right now is just use Helm. Just use Helm. Like just use Helm charts. This section here where it says chart, that is a very bare bones Helm chart. It's got the chart YAML, which has like a version in it. It's got your values file, things like that. Just use Helm. You can use Argo CD with Helm, or you can just have GitHub Actions if it has credentials to your Kubernetes cluster, you can just in the GitHub action run, I think it's Helm apply. I have to look at it. It's Helm something. And you just point it at this and it will do the deployment for you. That requires that your Kubernetes cluster be accessible, the API server be accessible to the internet. My Kubernetes cluster at home is not accessible to the internet. I mean, at least not. Some ports are, but only HTTP for Nginx ingress. So I run Argo because Argo will pull, and I don't have to expose my Kubernetes API server to the outside world. And that's why I go with the pull model for security reasons. And not most, quite a few companies that are using Argo, they are running it in a mode where they're pulling so they don't have to expose their APIs, their Kubernetes API servers to the internet. Yeah, it's common. Everyone gets real nervous when you are like one leaked config file away from some Russian being able to do whatever they want to your cluster, right? Like, yeah, I want to have to build a VPN as well and be able to audit all of that.
This might be outside of like, in terms of like, you have a time in CI/CD pipeline as well. It's like, what are the benefits of
just use ECS or the Google equivalent. There's a few. It's like there's like AppRunner or yeah. If you have a bunch of engineers and you need to be able to just have a big, like one or more decent sized clusters running a bunch of software, in-house software to each other, it becomes a bit unpleasant to run that many Terraform files, to run that many ECS clusters and configure all of the network and all the VPCs or whatever the cloud provider calls it. That becomes a bit painful. And in that environment, that's what Kubernetes is better, especially if you need to start writing operators and actually enforce like internal policies on how things in the cluster are working, and putting like resource management and other things around. If you need all of that, like you have hundreds of engineers, use a Kubernetes cluster. If you have less than 20 engineers, just use ECS or whatever your cloud provider's lightweight container orchestration services. It is not worth running Kubernetes to run 3 services. Yeah.
Yeah, because Kubernetes is very expensive.
Oh yeah. It's not cheap, and it's not cheap for the compute and the memory and all of that, and it's also not cheap for the engineers to run. Because for those not aware, when you run Kubernetes, you're on a treadmill. You are doing Kubernetes upgrades 2 to 3 times a year. You don't have a choice. Like you can let your Kubernetes cluster like just not get updated, but what you'll run into is every piece of software you run on it after about 2 to 3 years just will not support it any longer. And you will run into some bug, or you'll try to do something that you need to do, and you'll find out I now have to upgrade every component, like the networking component, the storage component, all the various components in the cluster. And just to be able to pull the cluster version up a couple of versions, and you're like 6 versions behind after 2 years. It's only run Kubernetes if you actually need the operators and the flexibility that it affords.
It was written by a cloud provider, so.
Yeah. Yep, and that cloud provider takes quite a bit of those managed Kubernetes clusters. Any other questions? We've run pretty long. Awesome. Well, thank you, everybody. Thank you for coming. Hope everybody has a long weekend.
Okay, yeah, so thanks again, Ryan. That's great. Great questions. Feel free to eat pizza and hang out for a little while. Are you going to tomorrow night after this? I probably will. Yeah, so if you want to bother Ryan right now or tomorrow night later, be available. Thanks for coming, everybody.